Thank you for the kind introduction, and with no further ado, let's get right into the content. So the opening slide that you see is something I took from Davos. Many of you probably know Davos. Davos is a small community in the Swiss Alps, but you probably also know about Davos 2017 and Davos 2016. But Davos 2017 was all about disruption and all about the fourth industrial era, and also about cognitive computing, AI. So in the course of our short talk this morning, I'm going to distinguish between AI and cognitive, so it'll be very clear as to what the two concepts perhaps mean and what their differences are. But let's go back in time for a minute. So if we go back to Davos 2016, they introduced this notion of the fourth industrial revolution. The reason I think that's important is because it's a background about why cognitive now and why is cognitive important. So when we think about the revolutions that we've had in our world, the first, of course, was all about the steam engine and the introduction of that. The second was all about electricity. The third was all about electronics and mass production. And what is the fourth? The fourth is what many call many different things. Some call singularity. Some talk about it with the intersection of the physical world, the biological world, and the digital world. So that's sort of the backdrop. But part of what I wanted to illustrate for you is that there is a significant event that has occurred over the last several years that has fundamentally changed how we build software, how we build systems. So let me first show you a demonstration of this, and let me give you some background on this demonstration. I'm going to show you a demo in a moment. It has no audio, so you'll only listen to my voice. But the purpose of what I want to show you is as follows. I want to show you the fact that in today's world, and this demo was built 2 years ago. In today's world, we can do something as early as 2 years ago that before we couldn't do for decades. And what is that? We can build a commerce. This is just a small example of many things that we can build. But think about this for a minute. What I'm about to show you was built in 5 days. So in 5 days, we built a commerce site. We built a site that had embedded analytics, a site that was exploiting mobility, a site that was exploiting cloud, a site that was exploiting social platforms. It could scale to hundreds of thousands of users. It could scale worldwide, and we didn't need to buy software from a single software company. We didn't need to buy hardware from a single hardware company. And we could do all of this using public APIs, and more importantly, we did it in 5 days. So when I show you the demo, what you're going to see at the bottom of the demo is the APIs, the application programming interfaces. These are public APIs. What you're going to see at the bottom is the public APIs that were in use. So they're just going to flash. Remember now, this is a commerce site. So this is about buying things. And hopefully it will move forward. 5 days to build, and so I'm doing something wrong with the clicker, obviously. To move forward. Thank you. So in the site that you see here, we're building an online site. We used Amazon to actually do the server environment. In this case, you see Eventbrite is the first API that's being used to announce to our community of people that we actually have a commerce site up and running. We've used Twilio to actually do programmatic messages to send out to people's cell phone. So Anna is the lady who's building the site. That's Anna. We're going to use Instagram to actually build a product catalog. So we're going to take pictures of dresses, because dresses are our products in this particular example. So we're going to load through Instagram our pictures onto a site. We're going to take polls to see what people like, and if they like the dresses that are being done. We're going to distribute it out to our social network. And you can see right now we've used Twitter, PollDaddy, Instagram, Twilio, and Eventbrite as APIs. So we now have a storefront that's up and running. This is our product catalog. We have a variety of dresses. We'll poll our community to see what they like. We will, of course, want to get paid for our services. So in this case, we're going to use PayPal as our secure payment and gateway engine. And now we've got a commerce site up and running. We need to see what sells where in the world. So we're going to use Google Analytics to do real-time business analytics to actually track what's selling and what's not selling. So now we've got those statistical information using Google Analytics, and we're done. We've actually built a site, and if you'll notice, we've done that with 7 APIs. If we wanted to spend more time, we could have gamified this, we could have added real-time shipping, we could have did campaign monitoring. So what was the point of this demo? The point of the demo was to show you the power of the intersection of 4 basic things, those 4 things being mobility and social and cloud and analytics. And the message is that this is the foundation that has afforded us this opportunity to look at cognitive computing. But this is not enough, and we've got more. So if you think about our computing environment, we have gone through, at a micro level, we've gone through different eras of IT computing. We started with the basic mainframes and minis. We then saw the invention of the PC, and we saw the era of client-server emerge. We then saw the introduction of the internet, and that era emerge. And now we have this new era, which, to be blunt, we can't quite describe. Some call it the 4th era of IT, some call it the next era of IT, some call it cognitive. But we're going to talk a little bit more about cognitive, obviously, in a moment. But you'll notice the technologies that make this up. We're talking about containers, we're talking about cloud, we're talking about virtual machines, we're talking about a world where the modern enterprise is actually building software fundamentally different than they did before. And what's unleashed by this new world are 2 waves of digitization. One wave of digitization is the one that we're all experiencing every day, which is around people-centered digitization. We see that with the consumer-based devices and social presence that we have. But IoT, the Internet of Things, is really at its formative stages. I know some of you, IoT is a really large field. In some cases, it's used as a market term, a marketing term. But if you go back to 1995, I realize some of you were very, very young at that point. But if you go back to 1995 and you think about the internet in 1995, we had very little imagination, I would assert, about the companies that now dominate our landscape, like Facebook and Google and Amazon. But the point is that we're at that same inflection point with the IoT. So the IoT is going to be a central technology, or rather, certain technologies will emerge out of that space. This picture is trying to just illustrate this 4th industrial era in a little bit more of a micro term, which is simply saying that we are now seeing 3 worlds converge. What are these 3 worlds? One of the worlds is one that many of us help build. It's the world of IT systems, whether we're talking about airline reservation system, banking systems, whatever. We've got IT. We've also got the world of you and I, of people. And then we've got the physical world that we live in. But our world is being increasingly instrumented. What's a camera? What's a sensor? What's an IoT device? Those things are increasingly vague. And there's been a lot of conversation. I believe one of the computer scientists named von Neumann was the first to coin the term singularity. And that term itself is expanding. But the point is that this is our new world, this convergence of technologies. The other thing that's interesting about this new world is that, unlike what we've done for decades, where we always moved data into a data center, into central processing, now we see a world where we have to push the processing out to where the data is. To say that in different, more practical terms, it simply means that we have more edge computing, and edge computing simply means that we have computing where there are mines, where there's oil fields, where there's farms, where there are cars. So we're pushing computing out. And of course, that means that we have to have a tremendous amount of, we need a tremendous amount of computing power to actually make that really work properly. So I offer this definition of cognitive not to say it's the correct definition, because if you do a search on cognitive computing, you will find the following. You will find that there's a tremendous amount of disagreement, or you could say the opposite. There's a tremendous amount of agreement. But the point is, there's a lot of varying definitions. My former company, IBM, is probably credited with sort of popularizing this term cognitive. In fact, if you do a search on your favorite search engine, you'll probably find more hits with IBM than any other firm. I'll let you decide what that means, but the real point I'm trying to make is that there's a blurring of lines between artificial intelligence and cognitive. I would assert that some points of view, if you go and look at the videos of Davos 2017, in fact, if you listen to the IBM CEO, she will simply say that she describes cognitive as an augmentation of artificial intelligence. And to some degree, you could argue, you could assert that that's sort of a political statement to deal with this fear that we have, which not that it may not be unfounded, that artificial intelligence gone awry could be a very dangerous thing. But we'll come back and talk about that in a moment. So I'm not going to make a distinction between artificial intelligence and cognitive other than the subtlety I just described, where when people talk about cognitive, they're talking about augmenting the human experience, the use of systems and people. When people talk about artificial intelligence, there's suddenly a range. And we're going to talk about this range. There's weak AI and there's strong AI. When people talk about strong AI, they're generally talking about reaching a state where you and I can no longer determine that we're actually interacting with an artificial thing, entity, whatever you want to call it, that we've suddenly reached a state of consciousness. But let's be clear. If you think of the human brain in the same way you think of the galaxy, which is not a bad comparison, by the way, and the reason I make that comparison is because, to be blunt, we know very little about the galaxy that we live in, the Milky Way. And we know about as much about that galaxy as we know about the human brain. So we don't even know how many neurons are in the brain, we guess. We don't know how many connections, we guess. So my point is that we've got a long way to go before we can mimic the human brain, because we don't fundamentally understand how it does many of the things that it does. But that's a conversation in and of itself. So this is one definition. When I talk about this next era of computing, this cognitive era, I don't know how many of you know this, but many of you probably do. There's a tremendous amount of invention going on in this space. I mean, Google, for example, for well over a decade has not bought servers. Facebook doesn't buy servers. Amazon doesn't buy servers. All of these companies manufacture their own hardware and software. This is why some of the incumbent technology companies are seeing decay. It's because they're being disrupted by these new tech companies, the Alibabas, the Bayous, the Facebooks, the Googles. And think about something that happened just in the last couple of years, which is Google beating one of the best Go players in the world. I don't know how many of you play Go, but it's a much more complex game than chess. In many ways, it's simpler because you've only got two pieces and they're black and white. But at the same time, when you start looking at the possibilities with Go, there's tremendous. So how did Google beat the best player in Go? Well, it was cognitive, it was artificial intelligence, and I'm using those two interchangeably. But they also had some special hardware. And that special hardware is this thing they call the TPU, the sensor processing unit. So think about NVIDIA. They're producing these graphical processing units. But why are these companies building this technology? They're building this technology because let's go back in time to 2011. In 2011, IBM launched a competitive platform to win on Jeopardy. That platform that IBM built took 2,500 core processors working in parallel with distributed processing to make that happen. Today, we have to put more processing power at the edge because we don't have enough time. There's not enough bandwidth to do this with cloud. And not that cloud is still not critical. So hopefully I've made the point here that we've got this new hardware. So quick taxonomy on cognitive computing.
When we think about artificial intelligence, I would assert we saw a lot of attention in the 1950s. We saw machine learning come about in the 1980s. And be careful. Be careful of vendors who package their 1980s technology as cognitive or AI, because it's not that it's bad, it's just that deep learning is really where the attention is being spent today. And that is a far more complex set of things in order to accomplish. So another definition of cognitive is software that combines the power of computing with brain-like intelligence. But remember what I said, we've got this notion of weak AI and we've got this notion of strong AI. This picture that I'm presenting to you is not a scientific diagram, it's not an engineering diagram, so don't look at natural language processing as being more, I sort of am saying that NLP is more on the weak side than on the strong side. I mean, look at Siri, look at Cortana, look at these technologies, and do they really understand you? Or are they simply doing some simple natural language processing and speech recognition? So the point is that there are things emerging like effective computing, this ability to actually sense emotion. If you think about some of the things that Microsoft has announced recently, glasses that do vision recognition using deep learning, using cognitive computing, where the glasses can actually help someone who is blind actually see the emotions of the person that they're talking to. This is where technology is going, but we've got a lot more investment in research in the way. But this picture, again, is simply meant to describe a lot of the various technologies out there. So when we look at this from a business standpoint, these are the sort of use cases that we see in play, whether we're talking about transportation, oil and petroleum, healthcare. These are the use cases, whether we're talking about building really nice virtual games, virtual reality games, whether we're talking about what I just described with Microsoft or with Google Glasses, whether we're talking about bots, the most common example are chat bots, or we've got these virtual assistants like Siri and Cortana. But why are these tech companies doing such a great investment in AI? I would assert it's because they see it in a world of ambient computing, a world where enchanted objects and things begin to sense our presence and respond accordingly. So these are the essential technologies, and it's not a complete list. I've inventoried a lot of these, but all of these technologies, machine to machine, IoT, all of these will be essential. And when you think about businesses, the companies that are not tech companies, but the companies using technology, they, just like with the fourth industrial revolution, are seeing a transformation in their own business. So this is a picture of the turn of the century, the 19th to 20th century, where we saw the horse and buggy and cars, and we're seeing the same thing in businesses as they shift to cognitive or to AI. We're seeing two entirely different IT groups. We're seeing on the one side an IT group that is largely dealing with this sort of modern technology. This is a simple application flow, and I'm going to end the presentation here. But when you think about cars and autonomous vehicles, this is trying to show what an application flow looks like. And the real point here is that you've got edge and you've got cloud. And there's some things that we simply can't do. We don't have enough bandwidth to send images back over the cloud to determine that this is a guy on a motorcycle moving at 80 miles an hour. This is something that has to be done at the edge. So this picture is simply trying to show you that these models that we train on the right in the cloud have to be propagated down to the edge in order to do safety, in order to do collision avoidance, etc. And so what is the future of cognitive? I would assert that we are seeing industries merge and transform. Healthcare is probably the biggest opportunity because there's such a tremendous, well, there's a lot of money in the space. That probably drives a lot of things, but there's a tremendous amount of opportunity to make the world healthier. So with that, I thank you for your time. I can be reached at any of these means, and thank you very much.